So let's talk about escape velocity. Now if you have seen or if you have noticed, say suppose this is your ground, and if you throw a ball, after some time the ball reaches a height h and then falls back down. Now if you throw this ball a bit with more velocity, you will see that the ball reaches some more height, that is h plus some h naught, and then again it falls back. So now you ask yourself a question: what should be the minimum velocity? We are talking about the minimum velocity required. The maximum velocity may be infinite, but what should be the minimum velocity so that the ball escapes from the gravitational pull of the earth and it goes on, that is it escapes the gravitational pull of the earth. So that is your question. Now this question can be answered by your conservation of mechanical energy. Conservation of mechanical energy. Now what you should know is that gravity, as I mentioned earlier, is a conservative force. Gravity is equal to conservative force. So now, if gravity is conservative force, then the work done is also conservative. So if work done is conservative and the force is conservative, therefore there is a conservation of mechanical energy that we can say. So no energy is lost during the above transition, that is no energy is lost, and all the energy is either converted into kinetic energy, either it's converted into kinetic energy or potential energy or both. That is, the energies will be interchanged between these two. So let's have a look. First, let us assume that the ball is in the surface of your earth. This is your earth and the ball is over here. Now in your book, I just want to clarify that in your book they have taken a height h. In your book they have taken a height h. So therefore the gravitational potential at that particular point, at this particular point, becomes G M then ME into RE plus H. So that is your gravitational potential. Gravitational potential. So in your book is given of this sort. This is your gravitational potential. Now what you have to keep in mind is that this N is nothing different. All we are taking is we are taking a point at the surface, and when you're considering h, you are taking a point which is h distance from the surface. So you should be very clear conceptually as to how we can interchange or how we can interpret the formula. So let's have a look. Now let us assume, now let the escape velocity, that is v escape, that is the initial velocity that we give to the object, for that the object escapes the gravitational pull of the earth, escapes the gravitational pull. The gravitational pull. So let that velocity be VE. Now what you have to keep in mind is that if this is my earth surface and if I give an initial velocity VE, that is, so I have a kinetic energy. I have a kinetic energy of half mve whole square. So this is my initial kinetic energy. And after reaching a point, that is after, say suppose I have taken another figure, this is my earth, and after reaching a point over here, let's say reaching a point over here, it escapes the earth's velocity. So the velocity should be just equal to 0. That is, final velocity should just be equal to 0 or tends to 0. It's the maximum, that is, we need the minimum velocity. We need the minimum velocity for the object to escape. So the minimum velocity will be given by when after throwing the ball, the velocity just becomes 0, but still it does not fall back. Still it does not fall back. That is the minimum escape velocity. That is, it has escaped the gravitational pull and still the velocity is 0. Now the object can no longer be attracted backward. So that is your escape velocity, and we are talking about the minimum velocity. So after reaching a point in infinity, we don't know what will be the distance. The final velocity is 0. Final v, that is final v is equal to 0. So the final kinetic energy of the whole system, of this whole system, is actually equal to 0. So kinetic energy is equal to 0. Now all that is there is your potential energy. So the whole of kinetic energy is converted into potential energy. So let's have a look at the calculation and how we can solve this mathematically. So now we know that the initial velocity, in your book it's given something like this. It is thrown with a height of h. It's thrown with a height of h. So the initial energy, that is initial energy at the height of h plus re, that is the radius of this, is given by half m v initial whole square. This is the initial, or you can say that the escape velocity, ve escape. This is the initial velocity or escape velocity, please do not get confused, minus g m by me whole divided by h plus re. Now this is the gravitational potential. This is the gravitational potential. Gravitational potential at that point. That is, therefore we know that this is a gravitational potential, plus you have a work done, that is W1. Now W1 corresponds to, now if you want to define W1, you will define W1 as a gravitational potential energy of the object at infinity. This is gravitational potential energy at infinity. So this is how we can define gravitational potential energy at infinity. Now we know that if there is no force acting, so sometimes what people assume this to be 0, because gravitational potential at infinity, that is, it has no potential. So sometimes people assume this to be 0, but in your book, that is in your NCERT book, this term has been taken. So we have assumed a term W1, that is the potential at infinity, and this is the potential at that particular point where the ball is being thrown. Now if you talk about energy at infinity, all that you have is m, that is kinetic energy, half m v final whole square plus w1. This is your potential at infinity and this is your final kinetic energy. So we know that by the law of conservation of energy, this two must be equal. That is, since gravitation is a conservative force, so no loss of mechanical energy. If there is no loss of mechanical energy, then that is energy at this particular point should be equal to energy at the point of infinity. So this becomes, if we substitute this two, this becomes W1 and W1 gets cancelled. So this becomes half m v escape whole square minus g small m mass of the earth into h plus re. This is h plus re, which is equal to half m v final whole square. Now, as I mentioned earlier, this velocity, that is vf, tends to 0 because we need the minimum velocity, that is the minimum escape velocity that we need, so that this becomes 0 and still it escapes the earth's gravitational clutches. So if we put this to be 0, then what we have is half m ve whole square is equal to g m me h plus re. So m gets cancelled. This is h plus re. Therefore, v square is equal to twice of g into mass of the earth divided by the radius, that is the radius at which the ball is being thrown. Now, we need to find the escape velocity from the surface of the earth. If the question is find the escape velocity from the surface of the earth, all you need to do is take h to be 0. So v square becomes twice g me by r, that is radius of the earth. So this is your escape velocity and v is equal to twice g me by re, that is radius of the earth. This is whole root over. So v minimum, now this is your v minimum, this is v minimum or v escape. Now there is another term that we know, and that is g is equal to g into me upon re whole square. The gravitational, that is gravity, that is the gravitational acceleration due to the surface of the earth. This is the term g, gravitational acceleration due to the surface of the earth. So sometimes you often come across a different formula, and the reason behind this is that they have taken or substituted this particular equation. That is, if I name this an equation 1, g equals to g dot me divided by re square. So if I put the value of g, or that is g by re, can also be written as root over of 2 g me into re divided by re whole square. We can also write this in this particular way. This equation has been converted into this, that is, I've just taken a re extra. So if I've multiplied this by re, I have to multiply this by re too. So gm into re divided by re whole square, and this particular term, now if you notice, this particular term gme divided by re whole square is nothing but your g, and this is what we have done in our previous classes. So if you have any confusion, just relate or just look into our previous videos. So finally your formula converts into v escape is equal to root over of 2 will be over here, 2 g re, that is 2 g that is acceleration due to gravity into RE, that is radius of the earth. So this is your escape velocity. Now please keep in mind from the surface. From the surface. So this is how you can explain the escape velocity.